Hello, everybody, and welcome to the Astro Show, a place to be if you're curious about the cosmos. I'm your host, Dr. Sam, the founder and executive director of Wyoming Stargazing. Here, you can pick the brains of astrophysicists, get advice from an aerospace doctor, find out what astronomers and other scientists have to say about life, and find out what's going on above your head all in the same place. So join us the second and fourth Tuesdays of every month at 6 p.m. Mountain Time right here on Twitch, YouTube, and now Facebook. We would love to hear from you, so you can chat your comments, questions in Twitch or YouTube, or you can call in using the Zoom credentials that you see on your screen. We would love to hear from you with your questions and comments. So don't be a stranger, give us a holler. On this week's show, we will chat with Dr. Alex Tichy, a distinguished postdoctoral fellow at the Academia Sinica Institute of Astronomy and Astrophysics in Taipei. Among other things, Dr. Tichy studies exomoons, and we will hear all about those later on this evening. But before that happens, let's welcome our co-stars. First, Assistant Professor of Physics at the University of Texas at Austin, it's Dr. Nick Golitsky.
Hi, everybody.
Hey, Nick. Good to see you. Next, published author, journalist, and creator of the Space Tourism Guide, it's Valerie Stymick. Oh, you're muted, Valerie.
Hi, sorry.
Oh,
Great to be here.
Good to have you here. Good to see you again. And last, but certainly not least, aerospace doctor and founder of Orbital Biodesign, it's Dr. Danny Carroll.
Hi, everybody. Good to be here.
Hey, Danny. Good to see you again as well. All right, well, let's get things going with astro advice, life advice from astronomers, astronauts, and other scientists. So I'll read the quotation, and then each of the co-stars will have an opportunity to guess which of the four possibilities of the actual quoter is the correct one. So the quote for tonight's show is, "I much prefer the sharpest criticism of a single intelligent person opposed to the thoughtless approval of the masses." So your four options for the actual individual who said that is A, Neil Armstrong, B, Albert Einstein, C, Johannes Kepler, and D, Edwin Hubble. So, co-stars, whenever you think you know the right answer, you can unmute yourself and cast your vote.
I'll go with Einstein on that one.
Okay, we got one vote for Einstein. Looks like Valerie's going Einstein as well.
I was going to say the same thing, but I feel like maybe I can
change it up, Danny. Change it up.
All right, we'll go with Hubble.
Okay, so we got two votes for Einstein, one vote for Edwin Hubble, and the correct answer is, next slide, please, Johannes Kepler. Yeah, interesting, right? So I actually,
with that.
What's that, Nick?
Just coming out of left field. Didn't think that. Yeah, all right.
Yeah, that was the kind of like the red herring in that list there. But so what do y'all think about this?
Well, I think it's a great quote because it reminds you that thoughtless approval is actually not valuable for moving us forward in any sort of conversation, whether it's the masses or an individual, that even just one person providing constructive, intelligent feedback is the best way to continue refining thoughts or ideas.
Yeah, I'm right with you on that one, Valerie. I prefer a good dose of constructive criticism opposed to placation any day of the week. Danny, were you going to say something?
I agree completely.
We We,
Yeah, it
we
doesn't
may
help.
be oddballs here, though. I think there's some people who do just like to be placated.
I mean, on Instagram, I'm fine with the thoughtless approval of the masses, but when I'm actually trying to talk about something intelligent, I would like people to engage at the same level. What's funny is that in my mind, I could hear this quote being spoken by a person with a German accent, which is why I went with Einstein, because he has a very particular voice. And Kepler was also German. So I
Yeah.
think my brain just kind of, maybe it's the way the sentence is constructed. It just sort of made sense that I could hear someone who maybe didn't speak English as their native language that they were born and raised in. I don't know what it is, but my brain was on the right wavelength, just the wrong era.
You are more of a linguist than I am. I got nothing like that. So I am impressed, Valerie. Nicely done.
Well, I got the wrong answer, so not that I could
Hey,
still got
but
room
at
to
least
improve.
you had the right nationality. That counts for something. Yeah, I'm one of these. I think people of the minority actually who really thrives on constructive criticism. I mean, I've kind of always been that way, and it just works for me. But I don't know if I have a sense of whether like other people like that. I've definitely put my foot in my mouth offering the same type of feedback that I like to receive. And so I'm curious about if the three of you, or at least, Valerie and Danny, you seem to be on the same page as me, whether you see yourselves as I am as kind of the anomaly, or whether you think there are actually more of us out there who like constructive criticism as opposed to just a little placation.
So in my mind, it's situation dependent. And I find that a lot of times folks will be very open to constructive criticism in certain areas of life and maybe not in others. And I think we're all probably true of that, or guilty of that to some extent, where maybe in some areas of our lives, it's like a little bit more delicate. I don't know, just a thought.
I think you're onto something there.
Yeah, there's a time when sharp criticism is not appreciated. I can think of several where I'm like, just wait till later.
Right.
If on the situational, yes. I feel like in this context, saying the thoughtless approval of the masses is a little dismissive of the masses. So I'll say, if I'm giving a talk at a pub, then I want the approval of the masses, maybe some thought, but probably not too much, because it's a talk at a pub. Versus if I'm giving a talk at a conference, then I definitely want some people to give me some sharp criticism so I can get some feedback on it. But yeah, seriously.
Totally, yeah, that nicely put, Nick. Yeah, if it's like science on tap, it's a little bit different than conference proceedings. Yeah, I like that.
I think this does ring true with this is I think a general piece of advice I think I've encountered a few times, which is, if you're writing a paper or a grant proposal or something like that, you got something big going on that you're going to submit. If all you're getting is good reviews, the advice is find new reviewers. Just say you really need to find people who will step outside and give you some criticism to make sure you are actually able to hone it to something better. So
yeah, I like that. And I'm just thinking about like Johannes Kepler now. I could bring this back to him and thinking of his mentor Tycho Brahe. So apparently Tycho Brahe was quite the critic, and wouldn't give Kepler his own data to analyze, potentially fearing that Kepler was a better mathematician than he was, which it turned out he was, which is why we have Kepler's laws of planetary motion and not Brahe's laws of planetary motion. But maybe that's where this comment stems from. Maybe it's like the student mentor relationship of Kepler and Brahe. I'm not sure what the context was of this quotation, but now I'm curious about looking into that. Were you going to say something, Valerie?
Making a kind of dig at Brahe.
I was just thinking about flipping the two important words in the sentence, which is intelligent and thoughtless. That really, he's only comparing two of the four options, because there's a whole hierarchy. You definitely prefer the intelligent approval of the masses above all. That's what you're going for in Kepler's laws. I think we can agree, like, achieve that level. And then the intelligent person's criticism, and then the thoughtless approval of the masses. And then what you really don't want in this world is criticism from a thoughtless person. That's I'd say the lowest level.
Yeah, nice. That would be the worst. Yep.
Yeah.
Any other thoughts on this one before we move on? All right. Well, there you have it. Thank you, Mr. Kepler. All right, on to Astro 365, this day and week in astrophysics history. So not too long ago on this day in 2003, the European Space Agency launched SMART-1, their first mission to the moon. There's been a lot happening with the moon these days, and so we thought we'd share this little tidbit of lunar history. This was kind of the ESA's attempt to get in the game, so to speak, to show that they could make this happen, and they did. Everything apparently worked pretty much flawlessly, and they did it with a close to record amount for a smallest amount of fuel, only 82 kilograms of Z9 fuel in their ion propulsion drive. And I mean, like, I've heard of like ion propulsion drives before, but really didn't know how they worked. So I actually looked it up. It's fascinating stuff. And I won't get into the details, but basically you're taking a gas and you're either adding or subtracting electrons from it by bombarding it with some other source of electrons. And then using a bunch of fancy magnetic prowess to shoot all those electrons into a cathode tube and out the back of the spacecraft to get propulsion. So pretty tricky way of making that happen. You still need a power source to get the electricity you need to make all that happen. And so it's got to be like a solar voltaic system or some kind of like nuclear system to provide the electricity. But yeah, pretty slick way of getting propulsion at a pretty low cost of the weight needed for fuel.
Yeah, no, it actually came up in my Inter E&M course a few weeks ago because it's a really practical example of accelerating charges in an electric field.
Yeah. Oh, nice. What did your students think about that, Nick?
They seemed interested. It's always a little hard to gauge, but I think they like it when I say, "Oh, here's actually a practical application. This is how you actually use this, technique to accomplish something." And it's like, yeah, this is a modern type of spacecraft engine, and not many of them have been made. I think it's only a handful that have actually been implemented in space because it doesn't provide a lot of thrust, but it can be consistent for a low payload. So if you're not in a hurry, it's great.
Right. Yeah, but you mentioned like accelerating these things, right? So they're like electrons are like, they don't have a whole lot of mass, right? So if you're thinking about thrust, right, it's either got to be like a whole lot of mass going the other direction or a lot of velocity going in the other direction to get momentum. And so apparently these little buggers get accelerated up to like 90,000 miles an hour. So that's the trade-off. It's a tiny bit of mass, but a huge amount of acceleration in the other direction of the spacecraft. And I had no idea that that's how that worked, but it kind of makes sense from like a basic physics standpoint. If you're dumping something out the back end to make thrust, it either better be really big or really fast. And the way they do it here is with something really fast.
Yeah, it's it's complicated to make in practice, but the like underlying physics of it is relatively straightforward, which is nice. It's like a fun way to do it.
Yeah. Valerie, were you gonna say something there? Yeah. All right, so we have made it to everybody's favorite part of Astro 365, the astronomy news quiz. All right, Valerie, I think we've got you up first this week.
All right.
Oh, no, sorry, we got Nick up first this week. My bad. We got Nick, and then Valerie, and then Danny, because Nick was our reigning champion from last week. Are you ready, sir?
Sure.
All right, here we go. Last week, the James Webb Space Telescope released its first images of this planet and its icy moons.
I actually showed that picture in class yesterday. It's Neptune. That's
Nice,
right.
it is Neptune. What a
Yeah.
shot, right?
Yeah.
Man.
Seeing the rings in infrared is a treat.
Yeah, so cool. So cool. Nicely done. 1 point for Nick. Here's another gimme. Yesterday, the DART mission successfully crashed into which small asteroid named after the Greek word meaning having two forms?
Which
One? Which one?
Might be messing up the pronunciation.
Like we can't give
It's
you,
Greek. It's all Greek.
we can't give you full credit for that. Okay, so go back to your Greek and Latin roots and suffixes here. So two.
So it's dimorpheus or something.
Yeah, there we go. Dimorphous, you got it. And if y'all haven't seen the video of this impact, we got a little GIF of it right here. It was pretty cool.
It's very cool.
Yeah. So it, I don't think the results are back yet about how much it was actually budged out of its orbit. But
I think it takes a while. A little disappointed that there wasn't a bullseye painted on the asteroid, but
I know, right? You think they would have gone up there first and taken care of that next time. I was really hoping they were going to do it like Armageddon style and like drop a nuke, but
geez, yeah. Why didn't they drill a hole first? What's going on?
I know,
I know.
silly.
I know there's some follow-up spacecraft, but I'm really hoping we get some good images of the crater.
That would be super cool. I mean, yeah, there is a little secondary spacecraft out there that's going to send back pictures and data. So hopefully we get a picture of the crater. That would be super cool. All right, you're 2 for 2, Nick. Last one, here you go. For the trifecta, which solar system object hosts nearly 16,000 pounds of human-made trash? Which solar system object hosts nearly 16,000 pounds of human-made trash?
Object, it's too small for Earth. I don't think it must be Mars, because that's where we shot all sorts of things into it.
You got it, man. 3 for 3. Nicely done, Nick. Yeah, isn't that sad though? 16,000 pounds of human-made trash.
When we say trash, do we just mean objects which no longer can be used, like
Yes.
spacecraft? Because
so
they're
it's
pretty
like
heavy, so it's just a handful of missions, really.
Yeah, it's not 16,000 pieces of human-made trash. But yeah, apparently if you add up all the heat shields and parachutes and everything else,
Well, is this also rovers that have run out of batteries?
This is also rovers that run out of batteries. Yeah, this is all human-made stuff left on Mars.
You can also think about the cost it took to get 16,000 pounds of material to Mars. That is higher than I would have thought, but I guess, we've been doing it for half a century now. So
yeah, that number I thought was kind of staggering.
Yeah.
All right, well, 3 points for Nick. So Valerie or Danny, you each have to get 3 points if you want to tie Nick for the lead. You got this. You got this. All right, Valerie, you are next. Are you ready for this?
Nope.
It's not like you have other things on your mind. All right, here we go. Earlier this month, which branch of the U.S. military announced they have lots of UFO footage, but would not be releasing it due to potential problems with national security?
I'm going to go with the obvious choice of the Air Force.
You are so close.
Well,
One more guess.
do we count Space Force?
We do not. No, not counting.
Okay.
We do. I mean, they're legit.
They
But,
are a branch of the military. They were part of
they-
the Air Force.
They were specifically, these UFO sightings were taking place over water.
Okay, my second guess was the Navy because I was
You
thinking
got it.
there's so much water on the planet and they're out where it's nice and dark and they can see all kinds of cool stuff up there.
There you go. Yeah, it was the U.S. Navy. And I must say, like, come on, U.S. Navy. Why did you decide to tell us about this and then not release it? I mean, like, that wasn't just a fluke. They actually thought this one through. It's like, okay, we got to tell people we have the UFO footage, but we can't actually release it. Why would they do this?
Maybe it's like a recruiting technique for hackers. Like, you know, guys are going to try and get in there. And if you're good enough to break into the Navy's databases to get UFO data, you should get a job for the government. That seems like that would be a helpful way to recruit people.
And we would love to see that footage if you are that person. So let us know. But yeah, I just thought that was like a weird PR move on their part, right? I mean, it didn't just happen. Somebody, like some group of people probably like thought this one through.
Yeah, what are they distracting from?
Yeah, that was my first thought. Nick. It was like smoke screen.
We have UFO footage. Don't look at our Bigfoot footage.
Yeah, something like that. All right, well, we're going to give that one to you, Valerie, since you were so close with Johannes Kepler getting the nationality, right? We'll put those two together and give you a point here for U.S. Navy. Okay, number 2. On October 8th, which meteor shower will be at its peak?
This is the Draconids, right?
You got it. Yeah, there you go. All right, 2 for 2. And last but not least, Lego Masters, a Fox reality competition show. This is real. If you haven't checked this out, you should check this out. It's pretty amazing. They returned to TV last Wednesday with an exciting guest appearance from who?
Okay, the question has an A, as like it's a title or it's a person?
It's a person. Yeah.
Okay.
Yeah.
Oh, there's 2 choices in my head and I can't decide which one.
You want a hint? You want a hint?
Does their name have 2 parts or 3 parts?
2 parts.
Bill Nye.
Nope.
Not Bill Nye. I don't know.
It was Bill Nye. No, I'll give you a hint. It's a U.S. astronaut.
A U.S. astronaut. There are a lot to choose from.
There are. Yeah.
That didn't help narrow it down.
A woman.
Oh, is it Peggy?
Not Peggy.
Oh, I don't know then. This is a good question.
It's Jessica Meir.
Ah, lovely.
Yeah. Yeah. So check out Lego Masters. It's if you're a Lego person, it's pretty sweet.
I feel like the engineering would be fascinating, even if you're not a Lego person, to the things they can make out of Legos.
Yeah, agreed. Okay, Valerie, you got 2 correct. Nice job. Danny, are you ready for this?
I guess so.
Okay. All right. Also, last Wednesday, which NASA mission's mega rocket passed its crucial fueling test?
I'm assuming this is referring to, and I've been a little bit living under a rock, but I'm assuming this is referring to Artemis 1, which was
It's Artemis 1. Still on the launch pad. We're hoping that it finally gets.
No, as of
Not anymore.
Okay.
Yeah, like 4 hours ago, they were wheeling it off and it disappeared with Hurricane Ian.
So
Yep.
sad. I was moving furniture 4 hours ago, so that's why I missed that
Yeah.
one. Oh,
I think-
I'm sorry to hear that. I was really pumped that this might actually be it, but
Me too. It sounds like it's going to be slid back to November probably.
no. We are still going to the moon. It's going to happen this year. All right,
100%.
that's 1 point for you, Danny. All right, here is question number 2. Last Tuesday, which country launched an Earth observing satellite from the Gobi Desert?
Um,
You want a hint?
Sure.
Location, location, location.
Oh, so an African country? Location.
Nope, not Africa.
I don't know. I was going to say China originally, but I guess that's
You
wrong.
got it.
Oh, all right.
All right. Yeah, I didn't know launches were done from the Gobi Desert, but apparently they are.
Mm-mm. Cool.
If you look up what this satellite was for, it lists a bunch of like observing, like Earth-based phenomena, yada yada, and like I'm reading this and thinking spy satellite,
like weirdly vague, right?
Yeah.
Nice.
Okay, number 3 for the tie. In 2 days, a Firefly Alpha rocket will launch from which Space Force, speaking of Space Force, Space Force base in California? One of the big ones.
I guess maybe Edwards.
Oh, not Edwards.
Oh.
Yeah, other big one.
Another big one.
Yeah.
What else is there?
ULA.
There's
ULA.
ULA is there.
What is that?
United Launch Alliance launches from the same.
Oh,
location.
ULA. ULA.
Yeah.
Okay.
ULA. Yeah.
It was Vandenberg.
Oh, okay. Yeah.
Vandenberg.
Oh, it's officially a Space Force base. I didn't realize that. It used to be an Air Force base.
Space
Okay.
Force base now, yeah.
Wow. Okay.
Yeah.
I've been there before.
That doesn't feel right.
Yeah. Hey, I don't make the rules here, all right?
I mean, you're talking to somebody in the Air Force, so I can appreciate that.
Yeah, no, I used to take Vandenberg seriously. Now I can't anymore.
I had to go in and update all my stories and references to it because it's like people were commenting, it's not an Air Force base. I'm like, well, okay.
Wow.
I know. I'm sorry, but I watched all the episodes of Netflix Space Force before I ever like really read any of the news articles about Space Force. So like I can't get that out of my head now whenever I hear about Space Force. So I need to somehow correct that, but I'm not there yet.
No, I just doubled down on it, Easy yet, but will.
Is there a new season even? I don't even know.
Yeah, I think that season 2 came out. I don't know. I think so though. I don't watch it.
I really enjoyed the first one. So
That's
Right,
with
it's John
Steve
Malkovich,
Carell.
right?
yeah,
Mhm.
Steve Carell.
Yeah.
Yeah, I really like him as a general. That works for me.
No, that's ingrained now. My impression is he's running it, and that's yeah, he's over there right now making this happen.
And whenever I see him, I think of Anchorman, and so that's really like the blend that I have in my head of like Space Force and Anchorman. Anyways, sorry, Space Force. I'm sure you are a totally legit military operation. I don't know anything about you. Yeah.
Just renamed all the bases that they used to launch stuff from, and everyone's a little bit not used to that yet.
Still a little bit bitter, maybe.
All right. Well, it is time for us to take a short break, and then we will be back with our guest spot with Dr. Alex Tichy. We'll see you in a few minutes. Don't go away. Hello, everybody, and welcome back to the Astro Show. We're here with our special guest, Dr. Alex Tichy, the Distinguished Postdoctoral Fellow at the Academia Sinica Institute of Astronomy and Astrophysics in Taipei. Alex, thanks so much for being here.
Thank you for having me. It's good to be here.
Yeah, it's our pleasure. Well, as always, we would like to start our guest spot with the same question, which is, what's the one question that you wish everybody would ask you, but nobody ever does?
Yeah, that's a tough question. I had to think about it a bit because I've been asked a lot of questions in the course of my life and my work, as so many of us have. Yeah, what I could come up with was can we give you a record contract? Nobody has asked me that.
Are you a musician?
Yeah, I am. I'm sort of being cheeky about it, but yeah, it's sort of my second great love is music. I'm these days more of a jazz pianist, but I write music and record it and you know, have a lot of fun with it. It's just, you know, just for my own sort of satisfaction, obviously. But you know, these days when people are musicians, they're not just composers, they're also, you know, audio engineers. They're doing it all themselves. You know, you really have to kind of be the whole package if you ever want to catch on. And that's my shortcoming, really. I love playing and I love writing, but the recording side of it is very challenging. I've just kind of had to figure it out on my own. But yeah, anyway, that's what I sort of moonlight as a musician, but I'm not getting a not getting a record contract. I don't think it's in the cards.
Well, I do hope you get one soon. Is there a place that we can go to listen to some of your music?
There is, but I'm not gonna. If people are really interested, they can go find me on SoundCloud, but that's all I'll say.
Okay, fair enough.
Sort of bashful about it. Like, I'm happy for it to be out there, as long as, like, my friends will be like, oh, like, can I hear your music? And I'm just like, yeah, like, if you find it on your own, because I don't. A little too shy about sharing it otherwise. But anyway.
Fair enough.
Got a secret stage name?
No, it's just my name. Yeah. I had a band a long time ago. And so then you can kind of, you know, you can come up with a name, but I feel like having a stage name is just, it's a little too, you've got to really be legit if you're going to have like a, if you're going to
What was the
something other than your name.
What was the band's name?
We were called the Archipelagos, and I don't, you know, I just thought it was like a cool word. And nobody could pronounce it, you know. So I don't know if you ever saw that movie, like that thing you do, you know, this movie about like this one-hit wonder.
The One Eaters.
They were called the Wonders, but it was O-N-E, and everybody would call them the Oneaters, you know.
Yeah.
And then they changed it. You know, it's like the Wonders, W-O-N, as in I wonder whatever happened to the Oneaters. And, yeah, so everyone was calling it like the Archipelagos. I love your band. I was like, this is a terrible name. And then eventually I found like another group that was also calling themselves that, you know, like the internet's a very big place. And so eventually I was just like, you guys stole the name. Like, you didn't do like a cursory Google search. Like, there's already somebody out there with that name. That's the first thing you do if you're picking a band name these days. You got to make sure somebody else isn't already using that name, you know?
Yeah, go after those guys for some royalties.
Yeah, we played like 3 gigs, you know. I mean, it was yeah, anyway, it was fun.
Nice. Well, very cool. Well, again, thanks for joining us. We didn't come here to talk about music, but I'm excited to hear that you're a musician. I used to dabble, but it's been a long time.
Yeah.
So you're in Taipei. Tell us about how you ended up in Taipei and how you ended up becoming an astronomer.
Yeah, so well, I guess I became an astronomer before I ended up in Taipei. So I guess we can start there. I you know, had sort of an unusual path because I studied to be an actor, actually. Originally, I went to school, got a whole degree in theater at New York University, and then you know, I mean, I don't think a lot of 18-year-olds are making like, you know, the best life decisions. I mean, you know, being an actor is great. I loved it. I love the theater. I love being an actor. But as far as the lifestyle of being an actor, it's very challenging. Not like you know, the lifestyle of an astrophysicist is a bed of roses, but all the same, I realized, you know, just in terms of the instability and all of that sort of thing, you're always looking for work. Your whole life as an actor is spent looking for the next job, you know. And eventually I realized that wasn't really for me, but I was quite young still, 25 or so. I was like, man, what else can I do? I'm like not trained for anything. What could I possibly do that I would find you know, really fulfilling? And eventually I got the idea in my head that I wanted to be a high school like physics teacher. I had started watching, like, I got really hooked on Carl Sagan, Cosmos. I read all of his books. And eventually I started writing a blog to just kind of like fill time. It ended up kind of catching on a little bit, where I would talk about science in a way that was sort of accessible for the public. And that's when I sort of got it in my head that I was like, oh, you know, I'm like kind of good at, like, I love teaching, I love explaining stuff to people in a way that's sort of accessible to them. And so I just went back to school and got a second bachelor's degree in physics. It was sort of weird thing to do. All my friends were getting, like, you know, really big, like high paying jobs, and I was like going getting a second bachelor's. It was a really odd thing to do at the time. But then I started doing astronomy research at the American Museum of Natural History.
Oh, cool.
And I got that's why I really got kind of hooked on it then. And that was the first time that I discovered that you can go and get a PhD and they'll pay you. I mean, I had no idea. I think a lot of people don't know that that's, you know, kind of how it works, at least in STEM fields, that you can, you know, go to school and have like a paycheck. You know, it's not a king's wage, but it's like, it was totally livable. So I was like, yeah.
Wait,
like,
you were getting 6 figures?
What's that? I'm making 6 figures. You know, I don't think I'll ever make 6 figures. But anyway, you know, yeah, you know, grad school, as we well know, is not for everybody. But for me, I didn't really see much downsides, because I was like, you know, I'll go and do something that I love for 5-6 years, and they'll pay me for it, and I'll come out at the other end with a degree. And like, where, you know, as long as it's not like affecting your mental health or like really kind of screwing it, you know, delaying other things that you want to do in your life. You know, there's definitely downsides, but for me, it was kind of a no-brainer. So I applied a bunch of places. I got accepted to Columbia, and I was there for about 5 years, got my PhD, and then it was time to apply for postdocs. It's the second part of your question. How I ended up in Taipei is just that you start applying for postdocs, you know, in your last year of your PhD. I was looking all over the world, but particularly in the US and also in East Asia. And so I applied for a bunch of jobs over here in Korea, Japan, China, and also Taiwan. And this one worked out. I had 2 job offers, one in Taipei and one in Shanghai. And for a variety of reasons, Taipei seemed like the better choice for me. So I was thrilled to get the job and came over here about 2 years ago.
Nice. Well, that's a great story. Tell us about Taipei. What do you think?
Taipei rocks. I really love Taipei. I think like a lot of people don't really know much about Taipei or Taiwan more broadly, but it's a fantastic place to live. I mean, you know, it's very clean. It's extremely safe. Yeah, everything just kind of runs efficiently. Like the subway system is really fabulous. Just like public infrastructure more broadly. I lived in New York City for 17 years, and the subways are just, in my mind, so bad. You know, dirty and constantly breaking down, and not entirely safe, especially these days. It seems to be sort of deteriorating. And to me, that is sort of a mark of a much broader kind of decay of like the government not really being able to address like the real fundamental needs of the people. You know, that New York is just like, the subway is the lifeblood of New York City, and to see it in like such disrepair is really sort of shocking to me. And so to come to Taipei, where like the trains are always running on time, it's always clean, it's just super reliable. And so that's just like, that's again, sort of like a marker of just like kind of how everything runs around here. The food is great. The people are lovely. We have these gorgeous mountains, great hiking. The weather is really, you know, it's warm. I hate the snow, honestly. I lived in New York City for so long. It's just like the icy, you know, the bitter cold of New York City. You know, Taipei gets a little chilly in the winter time, but we're talking like, you know, 15 degrees Celsius, or about, you know, 50 degrees Fahrenheit or something like that. It's kind of a rainy city, actually. The rest of Taiwan is more sunny, but Taipei is a little more kind of like Seattle, I guess, Pacific Northwest in that way. But otherwise, yeah, it's really a great place to live.
Nice. Well, I mean, yeah, you really painted a lovely picture there. I want to come to Taipei.
I'm going to get a job with the tourism board after I finish this postdoc, I think.
Nice. Very cool. Yeah, you know, it's funny. I've never been to Taipei, but my best buddy in high school lived there as a kid. His mom was an ESL teacher, and somehow she landed a gig there, and he grew up, and the stories that he loved to tell were about spearfishing. That's what he used to do as a kid.
Wow. That's
And-
wild.
Yeah, and that's all I remember about all of the stories is spearfishing in Taipei.
Yeah, I don't really see any spearfishing going on.
Yeah.
Maybe that's a thing of the past. People do go like fishing with the rivers. Actually, we have like lovely, the whole city is sort of surrounded by rivers, and they've done this really amazing thing where the entire riverfront, everywhere you go, is a park. And there's no buildings like directly on the riverfront. They have these like flood walls. I think that's part of it. You know, it floods a good deal. So they built these flood walls, but just, you know, for miles and miles and miles and miles and miles along all the riverfronts, just parkland. And so it gives everybody really easy access to the parks. And, you know, you have these sort of unobstructed views, and you can just ride your bike and you can go anywhere along the riverside. It's really, it's lovely, and people are out there fishing here and there.
Nice. Cool. Well, that sounds amazing. I will I'll definitely check that out someday.
Yeah, put it on your list.
I will. So your postdoc, what are you studying?
Yeah, so my research focuses predominantly on exomoons. I mean, you know, exoplanets obviously is part of that. So I, you know, dabble in some sort of exoplanet stuff too. But my main thing is exomoons. This is something that I got into when I was a graduate student working with David Kipping at Columbia, who is really kind of one of the pioneers of exomoon, the exomoon search. And actually, I had been into exomoons before I got to Columbia. It was something that I had kind of like, I remember like being in the shower one time and like being like, oh, exoplanets are really cool, but like, what about the moons? Because I'd always been interested in the moons of our solar system. The moons of our solar system are so amazing. You know, the diversity, geological features, and, you know, the possibility of life and everything. So I just remember kind of like one day just sort of daydreaming about like, well, how would you go about looking for exomoons, and starting to kind of like tease out ideas. And then I went and looked into it, and I was like, oh yeah, I guess there are like a few people actually working on this thing. So I'd had an interest in it, but as you know, like when you go to grad school, you pretty much just kind of have to work on whatever your advisor has got for you to work on. And it was just so fortuitous that I ended up at Columbia the same time that David Kipping started as a brand new professor. And I was like, oh man, I know this guy. And I was like, man, I'm interested in exomoons. He said, well, you know, that's really hard. But, you know, if that's what you want to do, I was like, yeah, you know, and it was hard. But you know, learned an incredible amount in that time. Obviously, we got a Hubble observation. We were responsible for maybe discovering the first exomoon ever, although it was certainly controversial then and remains so now, I would say. And then when it came time to look for postdocs, you know, again, you kind of apply, and a lot of postdocs are more project oriented. And I was sort of steering away from those because I was just like, you know, I could go work on atmospheres or, you know, any number of other things that are certainly cool, but a lot of people have just spent the past 5 years becoming real experts in that. I know next to nothing about those sorts of things. And in the meantime, I've developed this exomoon expertise that is really kind of rare. There's only a few, you know, handful of us really doing this kind of work. And I just thought it was sort of a shame to kind of like take a step backward. I'm always sort of advocating that we need to get more people into exomoons because, you know, you can't really make that much progress until you have the brain power, the human power, and also the funding, the interest from the community. You know, you really kind of need buy-in from the community if you want to make progress in a reasonable amount of time. So I'm always sort of trying to get more people to work on this. So I didn't want to step away from it, and I was very fortunate that I got this postdoc where they pretty much give me carte blanche to work on whatever I see fit. I think it's sort of special especially for a first postdoc to be able to just kind of work on my own projects and be my own boss. That's challenging in its own way. It's kind of nice to have marching orders from above sometimes. I don't have to like think through all my own problems. When I had a PhD advisor, I'd be like, yeah, like I'm so stuck, and he'd just be like, oh yeah, you should do that. I'd be like, oh, great idea, thanks, David. You know, and like now I don't have anybody like that. I just have to like come up with my own solutions and even my own projects. So it's challenging, but there's certainly a lot of work still to be done with exomoons. So you know, I haven't really run out of work yet.
It's a fairly new field, right? I mean, when was the first exomoon discovered?
Well, it depends on what you mean by discovered, but David has been working on at the Exomoon problem all the way back to, I would say, 2009, I think. So it's been a long time coming. The Kepler data, was challenging. I mean, it was fabulous for exoplanets, but exomoons are, just a little bit smaller, or maybe even quite a bit smaller, and so the signal to noise in the data is just not always quite there. So he'd been searching for a long time. When we finally identified this system, Kepler 1625b, that was in 2017. That was kind of like in the course of working on another project with David. We identified this single candidate object that sort of passed all of our tests, but it wasn't really enough for a slam dunk. And so we went and got a Hubble observation, applied for, it was my first Hubble proposal and I got it. It's a sort of beginner's luck, I suppose. And we got really an unprecedented observation there, 40 hours of Hubble staring at this object uninterrupted. Pretty much never been done like that. Even with those deep fields, I don't think that they were doing 40 hours straight. They stack a bunch of images together. But so this was a 40-hour transit observation with Hubble. And when when the time allocation committee awarded us this time, they assign you a staff scientist, and they're kind of like, yeah, I don't know if it's possible, we'll give it a go, and we performed the observation, and it came off without a hitch, more or less. But even then, there was still, sort of lingering ambiguities there that, rightly so. I think people looked and said, maybe it's there, but it's certainly not a slam dunk. I'd be the first to say that it's certainly not a slam dunk. But we tried to call it straight. So that was just 2018 was that paper that came out. So it's still fairly recent. And we've recently had another candidate that David and collaborators. I was a small part on that paper, Kepler 1708b, and that's another one of these exomoon candidates that sort of passes all the tests. But again, some lingering ambiguities there, and I think that's sort of just the nature of looking for exomoons. We got so used to exoplanets where you could really, see these hot Jupiters, and they would come around every couple of days, and you could just really like point your telescope there and be like, "Yep, it's there. I saw it." And exomoons are just a lot more challenging than that. So still a long way to go.
Yeah. So
And this is.
Oh, go ahead, Nick. Go ahead.
I was just going to ask: is this looking at it for transit? So you're blocking some of the light as the planet goes in front, and the moon would just be an extra little, I guess, percentage dip, or add a little step to the transit.
Yeah, exactly right. So that's we're looking at transits, and the thing about these moons is that they're going around the planet, of course. So even though the planet kind of comes around more or less like clockwork, the moon is always kind of showing up in a different place. And so if you know much about exoplanet science, they can take a lot of transits and sort of stack them on top of each other and sort of make like a much more coherent signal in the process. But like doing that same sort of thing with the moons is a lot more tricky. And as you said, these transit depths are very, very shallow, and so they can really sometimes I think when people put out a paper, or what the public sees in terms of transit, if they actually ever like look at a transit itself, it's like extremely clean, but that's been kind of worked over to remove all of these sort of astrophysical and instrumental effects that can be there's a lot of little bumps and wiggles in the light curve in practice, and those can easily mimic something like an exomoon transit. And so how you handle that data in a way that's sort of agnostic to neither introduce nor remove these very, very little signals, small signals that you're looking for, is it's quite challenging, as you might imagine.
Yeah, as kind of a follow-up on that is, do you look for ring systems? Is that something that would be interesting or indicative of moons around a planet, or maybe easier to find if you had a bunch of stacked images?
Yeah, it's a great point. So I haven't looked for rings in particular. I do know there's a few people out there kind of looking for it, and it's just as you say. That would be a lot more coherent. I mean, the signal would be very tied in close to the planet transit itself. But we should pretty much see the planet always kind of the same orientation, whatever the ring orientation is. You ought to be able to see that coming through, again and again and again. It would obviously sort of depend on the inclination of the planet, right? If we're seeing it like perfectly edge on, kind of like Jupiter, more or less like sitting edge on to the to the ecliptic, and then the rings would be extremely thin and we wouldn't see it at all. It'd have to be, you know, a little more tilted up, kind of like Saturn. So it's certainly possible, at least in theory. People have been looking for these sorts of things, but it's a little outside of my, you know, what I've been working on. So I'd leave that to people who know what they're doing a little more than me. Yep.
How many confirmed exomoons are there?
0 confirmed.
That's what I thought. I was like, wait a minute here. What are we actually talking about?
Yeah, 0 confirmed. I would say that there are, it depends on who you ask. I would say that there's 2 very promising candidates. And then, you know, there've been some sort of inklings of maybe exomoons actually from microlensing. There've been 1 or 2 papers about, you know, maybe we saw this thing out there. It's like a 3-body system sort of passing in front of a background light source.
I was just reading about one of those.
Yeah, so that's quite challenging. There's some degeneracies there, some sort of ambiguities in that data. The problem with microlensing is that, you know, you see what you see and then that's it. You never get to come back to it and examine it a second time. So, you know, maybe those have been detected. As far as transiting exomoons are concerned, I would say that there's really just 2 really sort of prominent candidates. That was 1625, Kepler 1625, and also more recently 1708. So not much to work on at the moment, or I should say, there's lots still left to work on because we still just have those 2. The thing about exomoons, you know, think about our solar system. Most of the moons where we find them are in the outer solar system, right? I mean, Mercury, no moons, Venus, no moons, Earth, 1 kind of big unusual moon, Mars, 2 tiny little ones. Most of the big moons are Jupiter, Saturn, Uranus, Neptune. That's really challenging from an observational standpoint, especially if you're thinking about transits. And then think about Jupiter has a 12-year orbital period, right? And Kepler had a 4.5-year time window. So you basically, just from a time argument, you have a 1 in 3 chance of seeing it transit a single time, and that's very little to go on. We really want to see something transit more often than that. And then that's setting aside these this sort of geometrical consideration, which is the farther away you get from the host star, the more perfectly edge on you have to be in order for it to transit. So that means that we're heavily biased towards these planets that are, you know, really, you know, close into the star, and have a, you know, comparatively paltry set of planets that are at a larger semi-major axis. So this is a challenge for us. Fortunately, we don't have to go all the way out to Jupiter. I mean, I think the simulations, the theory says that, you know, you could certainly have moons that are much closer in, or proper Jupiter analogs orbiting at, you know, 1 to 2 astronomical units or something. That's a little more manageable. But it is still sort of a precious subset of planets that we have to work with now. I think that those planets are out there. It's a matter of you know, building up the data set to actually to have a bunch of these things.
That's kind of what I was going to follow up with, which is, you've talked a lot about combing through Kepler data and modeling kind of what you would expect to see there. Do you also work on the simulation front of what kind of populations exist out there? Like, would we expect a hot Jupiter to have moons, or kind of what's it look like on that side?
Yeah, hot Jupiter's probably not, just from a stability standpoint. We have this thing, you know, y'all are probably familiar with this, but for the audience listening, the Hill sphere is this region of space where, you know, the gravity of the object in question dominates the gravity over external sources, right? So there's a region of space around the planet that is, you know, the gravity is stronger from that planet than, say, from the star outside of it. For a hot Jupiter, that Hill sphere is very, very small. At the same time, there's another limit on the close end of the planet side called the Roche limit. Get closer to the planet than the Roche limit, and your satellite gets torn to shreds. So for hot Jupiters, that region of stability between the Roche limit and the Hill radius is exceedingly small, and so generally we'd say that they just can't survive there. It's a little more finely tuned. So we'd want to look at planets that are farther away. I think there was some other piece of that question, but I've forgotten what it was.
Oh, looking at populations, like for those, you know, this is the big question, right? Is our solar system typical? Would you expect any gas giant outside a certain limit to have dozens of moons like ours do, or is that just an oddity?
Yeah, so that's not something that I work on directly in terms of building those systems. There's a whole bunch of people who are doing like hydrodynamic simulations of planetary, Jupiter analogs that have their own sort of disk of material as they're forming. So there's the circumstellar disk out of which the planets are forming, and then these planets, big planets, they open up a gap in the disk, and then there's material basically funneling down onto the planet, and then there's a sort of a secondary disk, a circumplanetary disk, out of which the moons form. And so there's been a lot of work to kind of see what happens there. How massive can those satellites be? One thing that I've been particularly interested in recently, and this is something that I've been working on with a student of mine, is to examine sort of the observability of planets with multiple moons. So believe it or not, the search that we've been doing basically the entire time up until now has always been a single planet and a single moon, right? So we're testing this single moon model against the data. But if you look at like Jupiter, Saturn, we have multiple big moons. So it's been something that's really sort of troubled me for a long time, that this very might well not be the right model for what we're actually looking at. And what are sort of the impacts of using this single moon model for a system that has multiple moons? Without going into the details, there's really sort of a variety of possibilities that I can envision coming out of using that sort of wrong model in essence. And so that's what that's more on the theoretical side. You asked about the theory, not so much generating the populations, but imagining that those populations are there and then seeing kind of what the observational impact would be.
Oh, very cool.
Yeah. I'm curious if there's any hope in using the James Webb Space Telescope. I know it's going to be looking at the atmospheres of, or hopefully atmospheres of extrasolar planets, but is there a possibility to use it for exomoon search as well?
Hey, you about to get 40 hours in that guy too?
Yeah, well, so it's certainly a possibility. My former advisor, David, and one of his current graduate students have been looking at, for example, what JWST could do. It's going to be an improvement on Hubble, certainly. So, it really would be a fabulous instrument to use. But as you well know, it's going to be hugely oversubscribed. There's a lot of science that people want to do with JWST. And so to get something like 40 hours is really crazy. I mean, even people thought that Hubble, that was sort of a crazy observation. Now JWST, people really gonna want to use that data. And it's not a sure thing. I think a lot of times people want to say, in these proposals, it's like, we're going to point the telescope there and we already know what we're going to find. And it's just, basically we're going to confirm it and it's going to be a beautiful observation, but it's basically a sure bet. This is not going to be a sure bet. And, or at least, with any sort of the candidates that we've looked at before, maybe we'll have something that's really, a slam dunk. Maybe see something in Kepler that we haven't seen. It seems kind of unlikely to me, but, Kepler actually, believe it or not, still hasn't been entirely explored. Every single system looked at for exomoons in a real intensive way, still yet to be done. We've got TESS. TESS is not, as ideal of an instrument as Kepler was actually for looking for exomoons, just because we have these short time baselines. But it's conceivable that we could have a real slam dunk case and then we could point JWST at it. But as you said, that's a long observation to get. If you really want to look at transits, you need to look at a lot. You need to stare at that star for a long period of time. It's not enough just to see the dip. You have to have a lot of out of dip data to calibrate. What does the star look like before the planet comes in? And then we're talking about a moon. It might be over here. It might be over here. So you need that steady baseline, and then you need that first dip, and then you need that second dip, and it needs to come out of transit altogether. That's just a huge amount of time to get with the JWST. So I think a lot about, what are other ways that we could sort of make these observations in a way that's a little less expensive. The problem is that, or one big problem is that, as you might guess, going to ground-based telescopes at first glance could be a very natural sort of alternative. We're building these huge telescopes now, and you could get some incredible data out of those telescopes. The problem is that the Earth spins, right? So no place on Earth can you get more than, maybe 12 hours is even pushing it. I mean, you're talking about, getting pristine data from the night sky. It has to be nighttime, and the Earth is spinning, and then you've got these huge data gaps. So, how can you get around that problem? Well, maybe you start thinking about, well, we'll perform an observation in Hawaii, and we'll perform another observation, halfway around the world, and, stitch together data from several telescopes. You have to have perfect weather at all of those sites. These planets, because they're long period planets, they don't come around very often. You might get 1 or 2 opportunities per year. Depends on, obviously, the orbital period of the planet. So there's so many observational challenges that have to be overcome somewhere. And, I think about, I don't know if anybody knows The Godfather, but there's this character in The Godfather named Virgil Sollazzo. And, he says, "You think too much of me, kid. I'm not that clever." And that's kind of how I feel when I'm doing this work. It's like, I'm just one person trying to think through these problems. And it's not nearly enough. There's a lot of people that we need to get more brains on this problem to solve some of these challenges, because I can't do it all on my own.
So you don't just need a record deal, you also need some new exomoon specialists.
That's right, yeah. And a dedicated telescope would be very nice. But that also...
we're gonna have one. If you can use a ground-based telescope, we're gonna have one in Wyoming in about a year.
Oh yeah, fantastic.
Be a shame if some observing time just fell off a truck, huh?
Yeah, for sure.
So I have a sort of philosophical question, which is, what is the goal of confirming the existence of exomoons?
It's a great question. So I don't know that we necessarily need to confirm their existence, in the sense that I think it's a great bet that they're there, right? Just kind of like exoplanets before, they've got to be there. Even the search for life, I would say, almost certainly there. The question is their occurrence, and what can that tell us about those other systems as well as our own? I think when we're doing any of this kind of work, we're really turning a mirror on ourselves as well. Understand, in what ways are we ordinary and in what ways are we extraordinary? So when it comes to moons, I think, that's a piece of it. Obviously we see a lot of moons in our solar system. Are they common? Are they rare in other planetary systems? I think that provides a number of insights. They also, I would argue, provide insights into the formation of those planetary systems as well as ours, right? So, as you know, we're here 4.5 billion years after the formation of the solar system. We have to piece together that history just from, what we've got on hand, whether it's meteorites or sort of dynamical observations of our solar system. And so these planetary systems are, they might be baby pictures in the form of protoplanetary disks, or we see these other planetary systems. We're sort of learning about how planetary systems form and evolve by looking at the dynamics. And so those moons similarly are kind of clues into those histories. I mean, again, I always kind of come back to the solar system. Look at, the moons of Jupiter, one thing, the moons of Saturn, we got Titan, and all these other sort of retinue of moons, the rings, obviously. Uranus is tipped up on its side, well, so are the moons. Neptune's largest moon, Triton, is a captured Kuiper Belt object. And now we're finding that, a good number of the Kuiper Belt objects similarly have moons. And so each of these things are sort of painting a different picture about sort of the formational history of those planets as well as the system more broadly. And so exomoons, I think, similarly, not when we just find one, that might be interesting in its own right. Kepler 1625, for example, if you believe it's real, that moon appears, based on our modeling, to be the size of Neptune, right? So you've got a planet that's a few times the mass of Jupiter, and the moon itself is Neptune mass. And that sounds like, well, maybe that's a binary planet, or what even is that? Our modeling suggested that this was like a 1% mass ratio. So that's like Earth, and Earth's moon is about a similar sort of thing. So you can comfortably call this a planet and a moon. But how can you make something like that? That was one reason why people were so skeptical to begin with. Like, I never heard of such a thing, a Neptune-sized moon. That's bizarre. It's the first thing any astronomer worth their salt said was, like, how do you make that thing? And then it turned out there were some papers came along and said, yeah, you can make it. But how common is something like that is another, sort of open question. You might imagine that that's kind of the lowest hanging fruit. Well, what's the first moon that we should see? Well, of course it should be this honking thing that's like, it's like so easy for us to see compared to these, Ganymede mass moons. They're going to be much smaller. So that's a new open question, right? Assuming it's there, and then I don't assume that it's there, but if it's there, then that's opening sort of new questions. And then finally, the search for life, right? That's something that is a powerful motivator for me. Certainly not for every astronomer, but if you look at the moons in our solar system, Europa, Enceladus, Titan even is maybe not a great place to look for life, but is an interesting astrobiological target. And so I would argue that these moons similarly, in the decades to come, are going to be just as interesting as the terrestrial planets that we're finding out there and are, calling out to us for characterization, but we have to find them first.
Good answer, sir.
I've given that answer many times. You asked about.
I was gonna say, that wasn't one of those. That definitely wasn't one of those questions that you haven't been asked yet.
I've been asked that a
Yeah.
few times, but very good question, important question to answer. Yeah.
I mean, that's one of my favorite things when I talk to people about looking for life in the universe is the flipping the transit idea on its head and thinking about another system looking at us and how small our planet is and how small our moon is relative to us. When you look at us transiting our sun, right? We're hard to spot too. So it's anything that's at anywhere near our level of advancement is just as hard to find us as it is to go out and find them from our perspective. And that always kind of surprises people that we are almost invisible in the light of our own sun. And that's why it's been so hard to find anything until the last few years. Absolutely.
Yeah, it's very challenging. Totally. For a sun-like star, our transit depth is really small, and there's astrophysical activities we well know. Looking at these observations of the sun, there's a lot going on the sun, and Earth is just kind of one tiny little dot in a sea of other dots. Sunspots is something that we actually, or star spots, something that we have to contend with quite a bit. These things are roughly the same size, maybe even larger than the planet. The planet passes, it's actually cool to see in the transit data. It can actually, one thing that kind of looks like a moon signal actually, is that a planet will pass in front of a star spot, and then now it's covering up a kind of a darker patch of the star, and so the light actually kind of just like goes back up, and so you'll have this sort of weird sort of bump and wiggle. It's not this clean transit like we're used to seeing. Some weird sort of contours there. It looks kind of like a moon, and so we have to think through all these sort of other possible explanations for the observations that we make.
I hadn't thought about star spots. That's got to be tricky.
Yeah, totally.
Well, we are just about out of time. Actually, we're over time, but we're always over time. So
I just looked at the.
It's always just about out of time, no matter what time it is. But Alex, are there any words of wisdom you want to leave with us, thinking back on your trajectory and becoming an astrophysicist and ending up in Taipei?
Or wow, words of wisdom. I don't know. That's really tough. I feel a little funny about trying to dispense any words of wisdom on the spot.
That's all right. Just thought I'd ask.
Do what you love, and you're still gonna have a job that feels like a job.
Hey, there you go. I like that.
I do love that tagline.
Yeah, being an astrophysicist, or any kind of scientist, it's a fabulous job to have. As you guys all know, it feels like a special privilege to be able to do this work. It's still a job, and you can have the ups and downs like any other sort of career. But all things being equal, I'm very happy to be here.
I'm glad to hear it. That's good. That was wonderful words of wisdom. Do what you love, and you'll still have a job. I love it. That's what I did.
But it's still a job. It's still a
Yeah.
job. Yeah.
Oh, yeah.
I don't live and breathe this stuff, you know. It's like, yeah. When I clock out at the end of the day, I like, you know, I'm like, I'll think about that tomorrow.
So you're saying you don't think about exoplanet or exomoons in the shower anymore?
Sometimes I do. Sometimes I'm like, oh man, I gotta fix that code. You know, actually sleeping on it, I fix a lot of coding problems in my sleep. I'll wake up in the morning, I'll be like, nah, that's how you fix that. Yeah.
I've been waking up like 3, 4 o'clock in the morning and having like some brilliant ideas. I think they're brilliant, like as I'm waking up. But
Right.
All right. Well, Alex, it has been a pleasure. Thank you so much for getting up early in Taipei to be here with us. Really appreciate it. Our operations director, Maggie, is going to reach out to you for a thank you gift. So thank you so much. And we really appreciate your time.
Thank you so much for having me. It's great chatting with you all.
Yeah, it's been a blast. So yeah, thanks again to Alex and to all of our co-stars. We couldn't do the show without all of you. So thank you for being here. The folks behind the scene, Maggie, operations director, and Gavin, our stream master. All of the board of directors of Wyoming Stargazing, all of our supporters, and of course, all of you there at home watching. Thanks so much for tuning in. We'd love to hear from you next time. But until then, till the next show, be well. And don't forget to look up. We'll see you then. Bye.